Okay, so if you remember, we ended with a formula for the sum of an arithmetic sequence. Okay, the sum of an arithmetic sequence, I told you there was a story behind that. And so we're going to learn about a mathematician, Carl Friedrich Gauss. Gauss lived, if you notice, from 1777 to 1855. Now, if you notice here in the first sentence, they sometimes call him the Prince of Mathematics. He's really famous, especially when it comes into calculus, because he's discovered a lot of things. And one of the interesting things, if you notice, at the age of 3, he informed his father of an error in a complicated payroll calculation. Stated the correct answer at 3. Okay? In school, when his teacher gave the problem of summing the integers from 1 to 100 to keep his students busy, he immediately wrote the answer down, that the sum of the integers from 1 to 100 was 5,050. Okay? And so this is a pretty smart kid. And this, where it talks about the 5,050, that's actually that formula that you wrote down yesterday. Okay? So let's look back at that formula, and let's figure out how he came up with 5,050 so quick. Okay? There's some differing views. They were thinking it was at 7 was when he came up with this.
Well, I think
now,
that
so if we were gonna sum the numbers from 1 to 100, this is what I want you to do. Is I want you to look at this and see what you see. No, I want you to think of where that formula comes from. Because we're adding the numbers from 1 to 100, and I already know the answer is 5,050. So the question is, how is it 5,050?
Just put 100 in red.
How could I get 5,050 from these purple numbers?
First of all, you gotta know.
What do you notice I get when I add 101?
101.
What do I get when I add 2 and 99? What do I get when I add 3 and 98? 101. So really, this is the thing. How many pairs of 100 and 101 do I have?
50.
50. So 50 pairs times 101 is going to give me 5,050. And so adapting that to this formula, n is your total number of terms. So in this case, 100 terms. So what n over 2 is doing right here, that divides it into pairs. Okay? This here, a sub 1 plus a sub n, is first plus last. Okay? So we're taking our first term and our last term, we're adding them together, and then we're taking them times the number of pairs. That's what this formula is. That's what he came up with when he was in elementary school.
For him.
That's pretty impressive. So let's go ahead and look at a problem. Find the sum of the integers from 1 to 800. So 1 to 800, so we're going to find s sub 800 equals. Okay, first thing is I need to figure out how many pairs. So I'm going to take 800 divided by 2. The next thing I'm going to do is take first plus last to find out what the sum is. So the first term is 1, the last is 800. So in this case, you're going to end up taking 400 times 801. And what do you get when you take 400 times 801?
320,400.
So the sum of the integers from 1 to 800 is 320,400. Now granted, could you sit there on your calculator and type in 1 plus 2 plus 3 all the way up until 800? Yeah, but it's going to take you a long time. So it's much faster to use this formula. Let's go and look at another one. Find the sum of the sequence. -5 plus 2 plus 9 plus 317. So if we're going to use that formula, what do I need to find? I've got the first plus the last. What don't I have? Number of terms. So I don't know how many pairs I'm dealing with. So I'm going to have to go ahead and use that formula that we had, the explicit formula from yesterday, to find out how many terms I have. A sub n gonna be? 317, because obviously I'm going to want to find what term 317 is. Okay, first term is -5. What is n? You don't know, that's what you're trying to find. What is d? 7. So now what I'm going to do is go ahead and solve that, and I'll be able to find what n is. So for very first thing I'm going to do is I'm going to distribute. So when I distribute, I get 7n minus 7. So really I get 317 equals -5 plus, oh, take that back. Not -5, what do I end up having? -12 plus 7n. Okay, so now let's go ahead and add 12. So I end up getting 329 equals 7n. So now what do you do? Divide by 7, so what does n equal? 47. So that means there's 47 terms. So now what we need to do is find the sum. So I need to find the sum of 47 terms. So I get 47 over 2. First plus last. So -5 plus 317. Okay, so what is -5 plus 317? 312. So if I take 47 divided by 2 times 312, what is my sum going to be? Somebody else get 7,332? Okay, so there you go. So on some of these, you're going to have to do a little bit of background work before we can even plug it into the formula. Let's go and look at another one. The 17th partial sum of the arithmetic series. 17th partial sum of the arithmetic series. Oh. So basically, I could do 1 plus 17 and add all those up, so I could find the sum of the first, second, third, and do all that. Or I could just find the sum of the first 17 terms. The only problem here is what? What don't I know in order to do this? I don't know the 17th term. So I've got to find the 17th term before I can even continue. And so to find the 17th term here, I've got a sub n equals a sub 1 plus n minus 1 times d. What's my d here? -22. Now, remember I'm finding the 17th term, so I'm going to plug in 17 for n. So 17 minus 1 is 16. 16 times -22. And then add 53, and what do you get? So 16 times -2 plus 53. -299. Somebody else get that? Okay, so if I plug in -299 here, so -299 plus 53. -246 times 17 over 2.
It's -2,090. Or 2,091.
Okay, so that's the 17th partial sum. Questions? Let's see what I got next. Oh, go back. There we go. No. Remember, sigma means what? Sigma means the sum. So this is the sum of n plus 6 from n equals 10 to 32. And so really, if I plug in 10, what is the first term in my sequence? 16. What is the second term in my sequence? Wait, how did you get 16? I plug in 10 for n.
17.
What's the third term? What's the fourth term? 20. Okay, so really when you think about that, if n is 10, I get 16. If n is 11, I get 17. If n is 12, I get 18. Okay, 13, 14. What do you think? If n is 32, what is that going to be? 38. So now, I need to find the sum of those numbers. So how many terms are between 16 and 38? And be careful. What do you think it is? Think it's 23? So let's say 23, so you have
20.
16, 17, 18, 19,
20.
20. There's 20.
It's
So 1, 22, 23, 24, 25. So there's 10.
It's 20.
Okay?
Because you
26,
said
27, 28, 29, 30,
you said in between 16 and 38.
So that's
That's
20.
31, 32, 33, 34, 35, 36, 37,
I knew it was 28.
20.
Ha, 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 ha.
23.
Yeah, but you said in
23.
You said in
23
between.
terms.
That's
There are 23 terms. So the number of pairs will be 23 divided by 2. And then I have first plus last. Let's go ahead and calculate that. So 23 divided by 2. 16 plus 38 is 54. So what do you get? There you go. That's your sum. All right, so what you need to do now is finish this section. Okay? So there you go. You should be able to finish this section. We are moving on tomorrow to geometric sequences and series.
Oh, baby.